All right, I'm back. We're still looking at 5.4. We've just sort of looked at the idea, trying to find the area under curve using left rectangles. Sorry if I ever said triangles. And right rectangles here, and more rectangles. And then we got this symbolism, which is read the integral from a to b f of x dx. And now we're going to do some problems involving this. This one says, number one, which rectangles are left rectangles, which rectangles are right rectangles. So what we need to do, and I wrote this down, left rectangle uses left endpoint for the rectangle height. The right rectangle uses the right endpoint for the rectangle height. So let's take a look here. I'm looking at this subinterval. That one is using the right. So the first one's asking about left. This one's using the midpoint. There are techniques using midpoint as well, but we're not. And this one's a left. So do you see that's a left? So C is left. That one's not left. And E is left. So C and E are left rectangles. Right rectangles. Let's take a look. So on this subinterval, that one's using the right. So I'm going to put A down. Write that down right now. And let's see, that's the midpoint left. D, that rectangle uses the right endpoint for the height of that rectangle on that subinterval. So D is the other one. Okay, that's the answer. Now, let's think about this in terms of area. This example I got out of the book, this says the area A right in here is 1.408. Area B is 2.475, and so on. It gives you area C and area D. Now, when you integrate, I'm going to tell you that integration will give you a positive value if the area is above the x-axis, and it will give you a negative area if the area is below the x-axis. It'll give you a negative value. The area is positive, but the integral can be negative. And then you're going to have positive value here and negative integral here. So this is asking, number one, the integral from, and read this properly, the integral from a to b of f of x dx. So I'm supposed to find the integral from a to b, so that's just from here to here. So it's this area A. I'm going to write that down. So I've got, this is number 3. This is area A, which is 1.408. Okay, so we're trying to connect integral, a definite integral with area. Now the next one says the integral from b to 0 of f of x dx, from b to 0. Here's b, here's 0. So that integral is going to be the area b, but since it's below the axis, it's going to be negative. So the integral can be negative, area cannot. Let's take a look here. 2.475 is the area, and negative means it's below the x-axis. All right, area from A to D, or the integral from A to D. All right, A to D, what is that? A to D is going to be what? A minus B plus C minus D. It's going to be A minus B plus C minus D. See that? Because A is above, below, above, below. So I'm going to take these values and 1.408 minus 2.475 minus 5.333 plus 1.792. And that is equal to, I don't know, I'll have my calculator out. I'll come back to it. You guys can do that in your calculator, right? I know you can. All right, let's go back to the concept. The integral from A to C, if I'm going from A to C, that's going to be A minus B plus C. So A minus B plus C, from A to C. So from A to C, so it's going to be A minus B plus C. And that's going to be, plug those values in, 408 minus 2.475, and then plus, did I do that right up here? Hold on, I didn't. I should have gone plus minus, this one's plus, minus, it's funny when you walk, zoom out with your head here. So we got a minus b plus c minus d. Okay, this one's a minus b plus c. Okay, I'll let you do that. Now the last one, the integral from c to 0 of f of x dx from c to 0. Now c to 0 is backwards. Okay, we can go 0 to c, but c to 0 is backwards. So I'm going to tell you a little tip here. To make this opposite, go from 0 to c, you just negate it. So from 0 to c, so I've got the negative, and then the 0 to c, what's that one? 0 to c is c, and that gives you negative 5.333. All right, you guys do these calculations up there. I'll be back with another worksheet. See you later.